This is the first video in a series exploring the practical value of digital threads, a key pillar of digital engineering. Here we will look at automated gap analysis, a regularly updated report on which requirements are linked or not linked to test cases and test results as part of an in-progress system development project. A digital thread is a means of making system data in multiple independent repositories, available in a connected, organized, and readily accessible form to all authorized users, to enable engineers and project managers to deliver projects on time, on budget, and with first-time quality. A digital thread platform like Syndeia from Intercax provides a comprehensive set of services with a unified API embedded within your integrated digital engineering environment. Engineering organizations use requirements repositories to manage the defining objectives and use cases of their system. In this example, we will use JAMA Connect, but Syndeia has equivalent integrations to Doors NG, Codebeamer, Polarian, Azure DevOps, and many other tools. These teams also use test management software to store test cases and test results. In our example here, TestRail. But again, Syndeia supports other integrations in this domain. A principle of systems engineering is that every requirement should be tied to one or more test cases and to test results that indicate whether it passes or fails. Syndeia maintains those project-specific digital links and can be used to create a gap analysis report which shows which requirements do or do not have assigned test cases and what the results are. Because this is a dynamic situation, it needs to be monitored periodically and automatically without ongoing human effort. Syndeia carries out these tasks using digital pipelines. These pipelines can be created in a variety of common CI/CD tools using the Syndeia API to carry out the tasks. In the case of Airflow pipelines, users can view and execute them inside the Syndeia web browser. Intercax senior engineer Gregory Seeds demonstrates a pipeline he created.
What the pipeline will do is it will sign into Syndeia. It will get that tree structure of JAMA artifacts. It will retrieve from the Syndeia digital thread relations from those JAMA artifacts to TestRail test cases, and for those found test cases, it will retrieve the information about the latest test run. It will construct a report that it will post to Confluence, and it will send a Slack notification. You can activate it with appropriate permissions by clicking the Run button. While it runs, we get a nice animation showing which tasks have succeeded, which are currently in progress, and which have not run yet. We can switch to the table view to see that same information up here, and also get a sense of how past runs have gone. This particular pipeline is scheduled to run every day at midnight. We can clearly see that one particular task, retrieving the tree structure of JAMA artifacts, is the slowest task. Our run is completed, and I have off-screen received a message from Slack showing that the report has been generated. The format of this report is very simple. First we have a summary, which shows metrics, and then we have details, which shows the information that goes into these metrics. The number of requirements in the JAMA system has been counted at 17. The number of requirements that have a test case associated in the digital thread is 10 out of 17, or 59%. When the pipeline retrieved the latest run for each test case, it found that 2 out of 10 are currently passing, a passing rate of only 20%. This information is based on live information out of each repository and out of the Syndeia digital thread. On the leftmost column, we have the structure of the requirements in JAMA, and we have hyperlinks which would allow us to, if we have appropriate permissions, click and view each requirement within the JAMA system. The center column is those test cases that have been associated in the digital thread to a requirement. And again, a hyperlink would let us go to TestRail and see the information there. Finally, we see the result of the latest test run for each test case. This first one, for example, is passed. The second one is blocked. Most of the others are untested, and here is the other passed one, bringing us to 2 passed out of 10.
This is only one automated use case involving requirements and test. We could reverse the gap analysis and look for test cases that have not been assigned to a requirement for a specific project. We can do impact analysis, identifying new requirements or changes to requirements that could impact downstream testing. And we could use pipelines to build the digital thread in the background, using either key attribute matching or advanced AI reasoning to identify and link related requirements and tests. These same capabilities can be applied across your integrated digital engineering environment, linking architectural, simulation, CAD, PLM, and simulation data into your digital thread. To learn more, watch for future videos in this series or contact us at Intercax.